Direct and inverse proportion. As an introduction to direct proportionality, a really common exam style question, especially on foundation papers, is those about recipes. For example, if you have a recipe that makes you 10 cookies and you need 100 grams of flour, 100 grams of sugar and 2 eggs, and you might get a question that says, well, how do we get a recipe for 5 cookies or 25 cookies? Well, if we know how much it is for 10 cookies, we can just halve all of those ingredients. If we know 10 cookies, we could think of a multiplier that we need to do to get to 25, so we could times by 2.5, or you could double it to find 20 cookies and then halve it to find 5 cookies and then add those recipes together. Another style of question which is given about direct proportionality that's in terms of words is rates of change. Now this could be about cleaners or bricklayers or rate of flow of water out of a tap. So let's think, it takes 3 cleaners 5 hours to clean a house. We want to know how long will it take for 4 cleaners. Well, it's important that we need to work out, well, how long would it take 1 cleaner? And here is where it's always backwards to what your brain wants to do. If 3 cleaners take 5 hours, just think to yourself logically, is one person going to clean faster or slower? Much slower. It's going to take them a longer time. How much longer? 3 times longer. Because they've got 3 less, well, they've got a third less of the people. So that's 5 times 3, which is 15 hours. So then once you've found how long it would take 1 cleaner, 4 cleaners are going to be 4 times as fast, so we can do 15 divided by 4. We can leave that as a fraction, or you could put that in your calculator. 7.5 divided by 2, so 3.75 hours. Then we come on to the slightly more difficult algebraic direct and inverse proportionality. So I just want to link these to their graphs. And an example of something that has a directly proportional relationship we learn about in physics, it's Hooke's law with the spring and the extension as you load masses onto the bottom of that spring. If you double the load, it doubles the extension. So let's just think of an example. Now this is the shape graph. We know it's a straight line through the origin. The origin is coordinate 0, 0. So let's think, if this is 2 and the value of y is 10, just answer me, what if the value of x was 4, what would you think the value of y would be? If it's a directly proportional relationship. Hopefully you said 20. Because as we've doubled x, you also double y. Now we can also think of this as, well, how do I go from x to y? 2 times 5 is 10, and 4 times 5 is 20. That value is constant, and we call this k, special k. It's very important to remember special k in terms of proportionality. So y is directly proportional to x. When x is 5, y is 15. Find y when x is 4. So this will be the style question that we would see. Y is directly proportional to x. So first we make our equation. Y is equal to k times x, just like we figured out here. The value of y was 5x. So we've got to find our special k. If it's directly proportional, we are doing our k multiplied by x. If it's inversely proportional, it's k over x. Now we substitute in what we know. When x is 5, y is 15. So here, 15 divided by 5k is equal to 3. So now we found our special k, y is equal to 3x. Find y when x is 4. And now we can do our final step and substitute in. 3 times 4, that's y equals 12. Let's try one more of those. Y is directly proportional to the square of x. When x equals 3, y equals 36. Find y when x equals 5. So y equals k times x squared this time. It's the x that's squared. Substitute what we know. 36 equals k times 3 squared. 36 equals k times 9. 9's into 36, 4, so k is 4. Y equals 4x squared. We substitute in that k in. Now we can do our final step. Find y when x is 5. That's 4 times 5 squared. Y equals 4 times 25. Y equals 100. So very similar with inverse proportionality, but instead of it's k times, it's k divided by. So let's look at an example question. T is inversely proportional to d squared. So it might not be y or x, it may be other letters. T equals 12 when d equals 8. Find t when d equals 0.5. So our starting is to put an equation together. T is equal to k over d squared, inversely over. Substitute what we know. 12 equals k over 8 squared. 12 equals k over 64. Now we're going to times that denominator over. 12 times 64 is 768. So t equals 768 over d squared. Now we're on to our final step. Find t when d is 0.5. T equals 768 over 0.5 squared. Pop that into our calculator. And we get an answer of 3072.